Thanks for the opportunity and that warm welcome. Always a pleasure to come out to Decentralized Science events. So this is going to be a bit of a departure from all the tech-heavy stuff we've been talking about recently and focusing more on the underlying infrastructure, which sometimes can be not as sexy as a new therapeutic or some computational platform or all the Web3 stuff we've been hearing about. So decentralizing science, in my mind, is built upon a few fundamental layers, right? The first is the funding layer, and the stuff that the VitaDAO team has been doing, we've heard about it for the last day and a half, has been incredible, obviously. The philanthropy stuff, and making sure the right incentives are set up for scientists. The second is the information layer, and a lot of work obviously happens on this level, whether it's sharing data, making sure publications and data are cross-pollinated well with scientists and engineers. But the third part that isn't talked about as much is the physical layer. In order to collect this data and use this funding, you still need the physical infrastructure, the labs, to go out and do this work. And for the next few minutes, this is what I'll be focused on, the physical layer and how we build to it. And as it stands right now, this traditionally happens in academia, which is great in a variety of ways. But as of late, there have been some massive trade-offs that you need to think about if you're pursuing this type of research within traditional academia. The drawbacks are, there's this immense pressure to publish. This term that gets thrown around is, publish or perish. And that's scary for a lot of people who might want to work on, very unconventional research that might have really, really large scale impact, but might not have the right data behind it. There's been a variety of publications on this topic, so I won't go into so much detail about this because it's been a topic that's already discussed quite well. When I talk to professors and PIs across the country, there's ever increasing amount of admin work they get to do. And this is not the best use of time for the brightest in our society. Whether it be reporting guidelines, whether it be grant applications, a lot of time is being spent pursuing these types of admin work. And then finally, if you're able to overcome this and find a way to bring your technology to the market, then you're in the business of dealing with what are called tech transfer offices to find a way to license or co-license and work with the university to spin that out. I was talking to a researcher a few days ago, and they spent more than 18 months being the top researcher at their respective university, just going back and forth with their tech transfer office because of how murky and how complex this system is. That being said, there's some positives too. And the biggest thing is it provides with the physical infrastructure to conduct this type of science. But what if I told you we can build this infrastructure outside of traditional academia? And can we do this? And this is the crux of the question I'll be going through in the coming few minutes. And the answer is we already have. Well, at least sort of. These are the set of labs that exist outside of traditional academia across the globe. There's more than 100 labs spread out all across Europe, all across Asia, a lot of them also in the US and Canada. So we're starting to build this infrastructure, and it's been really exciting to see this develop over the last 15 or 20 years. And just as a reference, just so I can frame this a little bit better, I break these infrastructure labs into 4 parts. First, there's these DIY labs. These are, by the way, not on that map. These are people who are just working out of their garages or apartments and doing cool stuff, which is great, but it will not hold the rigor of traditional science and get publication quality work. That being said, some interesting stuff has come out of it. If you know of the company Prime Roots, they're an alternative protein company that started in a garage and then eventually moved into a formal lab space. Then there are what are called community labs. These are usually just wet chemistry labs, usually biosafety level 1, and offer services that you can rent out from them on a membership basis, and are available with a variety of teaching and workshops on how to use specific equipment. So it's a really low entry bar, especially if you want to get into doing science and this is sort of your first time getting into it. Then a bit more serious are what are called incubator labs. Usually they have wet lab space alongside with assembly spaces, sometimes even some manufacturing capability, now leading into BSL1, BSL2. So you're getting more rigorous, but typically it's around startups or projects that are well funded, because these are bigger facilities that require a bit more funding and higher rent costs. Some of them will even take equity. And then finally, our specialized labs. So these are the high BSL labs that work with, various infectious diseases, clean rooms, nanofabrication centers, cost millions and millions of dollars. But again, you can rent these out as corporations or even privately. They just come at a higher price tag. Now, for the purpose of this talk, I want to focus primarily on these two categories: building more community labs and incubator labs. These are the two places where I think we're going to have the most bang for our buck as we scale the decentralized science movement. We already have more than 80 of these types of spaces spanning across North America at capacity. Now, depending on how optimistic you are or how pessimistic you are, you can look at this one of two ways. This is already a lot of great work. These labs are filling up and science is coming out of it. But another way to look at it is this is at capacity and there's a big supply and demand problem. I was at GenSpace, which is a few blocks away from here, or a few subway stations away from here, and they have 60 members for something like 1,500 square feet, which is really, really crowded, and it makes it really, really tough to build science when it's so crowded, when you're sharing the space with a lot of people. So what's the solution here? And if it's not staring you in the face, it is to me. I think we have to build more lab spaces. So why do this? And what is the case for this? First and foremost, it's the intellectual freedom. When science was in its heyday, and I mean, it's still growing at a massive pace, but there was more room for cowboy science. There wasn't this high publish mentality, or if you're a company and working under a corporation, there's this pressure to get to an investor outcome, or the outcome that an investor wants out of you, which has lost this intellectual freedom that are given, except for these special foundations and very specialized private labs. And I think we have to distribute that and truly make it decentralized. Second, as I mentioned, a lot of these labs are filled already and are brimming on the seams, which means there's a big gap in the market when it comes to the supply side. There's a massive demand, and we cannot offer enough lab space for people to, whether it's building their own companies or whether it's just working on cool projects that will have some fundamental outcome. There just doesn't exist enough lab space. And finally, given how markets have turned and how much technology has progressed, it's surprisingly cheap. That space that I was talking about earlier, GenSpace, they take on average about $500,000 a year to operate, and about startup costs are just about the same. So it's significantly cheaper than you think, especially with sort of the mentality that you can rent this space out. There's also very interesting business models that you can pursue around going down the incubator model, where you end up taking equity and it becomes a bigger financial play. So my ask for this crowd, and for those of you that are interested, there's this massive supply and demand dichotomy. And I want somebody in the audience here, and I certainly am, I want someone to take advantage of the delta between the abundance when it comes to building labs and the value that can be generated. Right now, we're in this sort of scarcity mindset when it comes to lab space. And there are people in the crowd that I know I've been speaking to that are starting to build these spaces. I want to keep this short and leave you on two parting thoughts. Number one, I've built over the last decade, I've built 2 lab spaces like this that have led to the formation of companies. Some really cool research has come out of there. There's other labs that has led to companies like OpenTron's, the automated lab system being created. Therapeutic companies have started at these sort of community labs. So I want to make a case for you to consider building labs like this or funding labs like this. I'm building a playbook for those of you that are interested on getting something like this off the ground and what it takes. And then second, if you've already built labs like this and have experience running labs, I'd love to hear from you and get feedback, build this playbook together, and see if we can make a dent in this space. So thank you all for your time. It's been an absolute pleasure being here. Really, really awesome to be here.
Thank you very much, Harry. So we'll take some questions, and just a comment from myself. I'm well aware that it's extremely time-consuming and difficult to start up a community biotechnology laboratory, so it's not easy. So I don't know if you have do you have any tips for people that would like to start? I certainly have some, but it's not for the faint-hearted, like any startup.
Yeah, this is one of the cases. I'll push back a little bit on the hard. It's actually not as hard as one would think, having done it twice now. When I first walked into it and realized, I definitely thought the mountain was going to be much bigger than it actually is. Yes, you need to worry about, variety of safety measures and the right documentation, but a lot of this has been done. None of these are 0 to 1 problems per se. They've been solved in different capacities in a variety of infrastructure problems already. So there's a lot of knowledge share that's out there, and I'll be sharing this, by the way, openly afterwards as well. And I'm happy to make a lot of that public. As far as the funding goes, that is a challenge sometimes, though there has been a lot of interest as of late, combination of the Web3 world as well as other private investors who want to get into this space. JLabs has made, tons and tons of money down this path, so has Roche and a variety of other companies. The hardest part in this is battling the real estate challenge. So in New York, it's significantly harder to set up a space like this versus St. Louis, where, somebody in the audience is building a space in St. Louis as an example, where the rent costs are low and economically it makes more sense. So it's hard-ish, but there's a lot of support already exists to go solve these problems.
Yeah, I mean, maybe things have changed right now, but starting GenSpace years ago, the real estate was we lucked out starting it in Brooklyn. So there's a lot of luck involved in getting that off the ground, as well as getting the right people together. So I guess another question I have here, how has it become easier over the years to start up a community biotech lab or the other variant that you mentioned?
Yeah, so
resource-wise, is there things available now that weren't available 15 years ago?
Well, yeah, you can go on eBay right now and buy -80 freezers that would cost thousands and thousands of dollars for a few $100s and get it secondhand in really good working condition. The other part is also building a community of expertise. The reason why people work in academia, and academia is so good at this, is they can have a lot of knowledge share with their colleagues, and you can turn your shoulder over and walk down the hall and talk to somebody who's working in the same area. That's another big part that's missing. But I think that part will come over time. As far as infrastructure costs and resource costs, a lot of that has actually decreased. The real estate part, as you quite rightly mentioned, is tough. So in places like New York and some of the larger cities, it's going to be tough. But there's a big gap in, for example, the Midwest. I can pull that map up. There's so many blank spots where at least I hear of, researchers who are dying to enter a space like this.
Do you have any questions from the audience? Yep.
Do you see community labs moving towards the traditional CRO field? I mean, from intellectual standpoint, from the consulting, or from the physical operation, to accepting money for the service, so you can grow your material base and your the network of experts and account the expertise and the material possibilities more efficiently?
Yeah, that's a really good question. In one sense, yes, where there have been a few examples where these community lab space will offer services or experiments, and this is becoming more and more easier with a variety of lab automation tools that are out there. So you can automate a big part of the process and have a service layer on top and sell it as sort of this product service offering. Though I'm not sure if this is the role of a community lab. Just because it's more that CROs will want to do this as a side service more than the other way around, where community labs will want to become CROs, in my opinion. Just because their model is much more community focused, and a lot of these are run as non-for-profits, except for the incubators, which have a relatively simple and easy incubator equity model operating closer to VCs, sometimes going down the venture studio path. But I don't see it as a new revenue stream based on CRO services. But I am seeing a trend going the other way, where CROs are starting to offer their space up to startups that they want to work with, potentially partner with down the road.
Hey, great chat. I know that you said of those 4 different phases of labs, you're mostly focused on 2 and 3. But do you think there's anything that can be done for those like garage labs that would make their work sort of more acceptable downstream to sort of, let's say, inspire more funding? Like, is there any way they can make their work more verifiable or reproducible or anything of that nature?
Yeah, that's tough on 2 levels. Yeah, it is possible, but there's 2 challenges that need to be overcome. The first challenge is usually the people that are setting up these garage labs or apartment labs don't have a scientific background. They haven't spent that much time in the lab. So there's a matchmaking problem when it comes to if you're able to find the right mentor. Like, for example, I use the Prime Roots example. Kimberly, who's the founder of that company, she had technical experience before, but she had to build this apartment lab in COVID just because she couldn't go out. So there are exceptional cases where the garage lab is run by people with experience, but that's usually not the case. So there's a matchmaking problem there. And then the second part, obviously, is infrastructure limitations. You cannot have special power requirements and rejig the electricity. You cannot install fume hoods into a garage, or it will be really, really tough. So those are the 2 limitations that need to be overcome. That being said, there are certain industries that do really well without that sort of infrastructure need. For example, a lot of work we're seeing is happening in synthetic biology that you can get away with. But you cannot go down, building a novel drug or a molecule in a garage lab. So those are the 2 challenges that need to be overcome, in my opinion. But that being said, as a curiosity, as a, garage scientist, great, go do it. It's just, it will have those limitations.
I'm wondering if there could be a focus on biological material transportation to allow collaboration between labs while maintaining experimental integrity, because that way you could if there's equipment in one lab versus equipment in another, you can share resources much more effectively.
That's interesting. I've actually not thought about that in so much detail. Usually what I've seen happen though is if, let's say, you have some specialized equipment that I don't have, it's easier for me to either come to you or run that experiment in your lab rather than transport sort of large equipment over. Another thing that's been really interesting is with a variety of lab automation tools that are out there is just getting access to special machinery that you might have and running experiments like that.
Yeah, actually, I wasn't talking about the equipment itself, although that might be an interesting model if it's within a city or something like that. But the specimens themselves, if you need to process them on one machine and then, take it to like a mass spec, and then that way you can transport it between labs that have, specialties or specialized equipment, the samples themselves with high integrity.
Oh, I see what you mean. Yeah, I mean, that's why certain clusters work really well. And that's why these specialized labs, the category 4 is really important. One of the best ecosystems I've seen develop is in a small town called Waterloo, Canada. Some incredible stuff has come out of there. And the reason is they've been really good at cultivating that ecosystem. Number one, University of Waterloo has a free IP policy. So no matter whether you're a prof all the way through a student, you own your own IP and you don't have to deal with tech transfer office. So it's relatively anarchist in that sense, which has been really great for innovation. The second part is, to your point, they have this infrastructure that you can rent out any equipment on a time basis. You can move specimens along, but it's within a relatively closed geography that's all within tens of kilometers of each other. That makes it really easy. So there's value to proximity for now. I think with some of the automation tools, we'll get rid of that as time goes on, but we're still some years away from that.
All right, thank you very much.
Yeah, thank you, everyone.